Hey everyone, and welcome to this MathQuest Explainer. Today, we are embarking on a journey through Unit 1, Lesson 1, Properties of Proportion. Think of me as your friendly, built-in AI robot guide, here to help you tackle this topic with absolute zero anxiety. Here is our roadmap for today so you know exactly where we're headed. First, welcome to MathQuest. Then, what is a proportion? Extremes and means explained. The cross-multiplication magic. Real-world proportionality, and finally, let's practice together. Okay, let's dive into this. Section 1. Welcome to MathQuest, your interactive learning journey. I am so excited to be leading today's session. As your trusted AI guide, my whole job is to simplify math for you. We're building a totally safe, approachable space here. We're going to break down those tricky rules so that absolutely nothing stands between you and mastering this curriculum. Our core mission here at MathQuest is simple. Tackle math with confidence. That's the vibe today. By the end of this explainer, I want you looking at a fraction or a ratio and feeling totally empowered to just solve it. Section 2. What is a proportion? The concept of perfect balance. We're not going to treat this like some scary rule, okay? Just think of it as a perfectly leveled seesaw on a playground. So, when we say quantities A, B, C, and D are proportional, it literally just means the ratio A over B is exactly equal to the ratio C over D. In other words, a proportion is just two ratios that are perfectly equal to one another. They represent the exact same relationship, just written with different numbers. And this brilliantly illustrates the whole idea. Look at the left side, our first ratio, A over B. Now look at the right side, our second ratio, C over D. That equal sign in the middle? That's the fulcrum of our seesaw. The left side and the right side act like two equal weights, resting perfectly on a scale. If one side changes, the other absolutely must change proportionally to maintain that perfect balance. Section 3. Extremes and means explained. Naming the parts of our equation. Because, hey, before we can do magic with these numbers, we actually need to know their proper names, right? When we write out A, B, C, and D in order, the very first number, A, is called the first proportional, and the very last number, D, is the fourth proportional. Because they sit on the far outside edges of our relationship, A and D are officially called the extremes. Kind of a cool name, right? Next up, we have our inner numbers. Our B is the second proportional and C is the third proportional. Because they sit right in the middle of our list, they are known as the means. Section 4, the cross-multiplication magic, bringing the balance to life. Now, what's really interesting about this slide is that this is where we get to the most powerful tool in the whole lesson. Watch this. When we have A over B equals C over D, we unlock the equation by multiplying diagonally. Step 1, we multiply the extremes, A times D. Step 2, we multiply the means, B times C. Step 3, we set those products perfectly equal to one another. Just like that. We've transformed a fraction problem into a super simple multiplication problem. Which brings us to the golden rule of proportion. If A over B equals C over D, then A times D will always equal B times C. The product of the extremes equals the product of the means. Seriously, if you remember absolutely nothing else from this explainer today, etch this rule into your memory. It is literally the master key to finding any missing value. Section 5. Real-world proportionality. Math and ancient history. You know, people always ask, when am I actually going to use this? Well, let's look at how these invisible rules apply to the real physical world around us. We're taking a quick trip to Egypt. From the breathtaking golden mask of King Tutankhamun to the magnificent Egyptian Museum in Cairo, the math concepts we're learning right now are tied directly to these stunning historical examples. So, imagine a marketing team working for the Egyptian Museum, running a huge online advertising campaign. They noticed something pretty amazing. The cost of the advertisement, the number of times it appears on screens, and the number of actual user interactions are totally proportional. They use these exact rules, our extremes and our means, to calculate things like the rate of views per hour to ensure their campaign is perfectly balanced. How cool is that? Section 6, let's practice together. Applying the cross-multiplication property. All right, grab your pencils because we are going to tackle a real problem together, right now. Here we go. Let's find the fourth proportional for the following sequence of numbers, 8, 12, 14, and a mystery number we will call x. Because x is the fourth number in our list, it's our missing extreme. Let's build this step by step using our logic. First, set up the balance. 8 over 12 equals 14 over x. Next, cross-multiply. The product of the extremes, 8 times x, equals the product of the means, 12 times 14. So 8x equals 168. To isolate x, all we gotta do is divide 168 by 8. Boom, 21. And there we have it. By using the properties of proportion, just setting the extremes equal to the means, we effortlessly found our missing number. You can tackle literally any missing value with total confidence now that you know the secret. To wrap up our explainer today, I'm leaving you with a slightly more advanced puzzle to test out your new superpowers. If the quantities a, 15, 20, and 3a are proportional, can you use cross-multiplication to find the exact value of a? Grab some paper, set up your ratios, and balance that equation. Thank you so much for exploring MathQuest with me today, and keep practicing.